Hello and welcome back to the last set of examples here. This is going the opposite direction, so this is factoring. So what we want to do is we want to take the given terms and we want to move it back to this form. And I have to give you questions that work back to this, so your goal is to get it back to that. So here's your strategies. So you know you're getting back to the exponent. First one is to count terms. So count terms. That's step one. So we have 1, 2, 3, 4, 5, 6 terms. 6 terms would mean that this expression is to the exponent 5. Second, we know that from the previous note, that first term in the expansion, so if we look at x to the 4th, it started with the first term here, x. Okay. Similarly, x to the 6th comes with the x to the exponent 6. So we know that's going to be that first term to the original exponent. So if we look at this, we see that we're dealing with a 1. So that means that there was no variable. So the first term must have been 1 to the exponent 5 to give us that 1, because the second term would be to the exponent 0. So look at first term. To determine the original value. Now, the other thing that I see right away is that it's adding all the way through. So that means that it must be a plus sign here. Determine sign. And the fourth is look at the last term. So if we look at the last term, it's 32x to the 10th. So we know the last term was something to the exponent 5, and that is because of this exponent here. Okay. So that means what goes in there? Well, to make the x to the 10th, that means that the exponent on it was 5, so it must have been x squared originally. So x squared, that gives you x to the 10th. So it must be x squared. But there's also a number, there's a 32. So we need to figure out what's the exponent 5 gives us 32. And you can do this with the calculator, but it turns out that 2 to the 5th is 32. So the 2 goes in there. So there's your final answer. So you basically just need to know how many terms, first and last term, and the signs in between. So for the second example, B part, we have 1, 2, 3, 4, 5 terms. So that means that this would be to the exponent 4. So we've done the first one. Next, we look at the first term to determine the original value. Well, it's x to the 4th there. So we know that we're going to have our initial term was, our overall exponent was x to the 4th. Okay, so x to the 4th, but now there's a number in front as well. So we're asking ourselves, what number to the exponent 4 is 16? And again, trial and error with the calculator, or some people will see right away that it's a 2. So the first term in this expansion is 2x. Next, we look at the sign. Now it's alternating. All you need to know, if it's alternating, it must be subtraction. If it's all the same, it must be adding. Finally, we look at the last term. The last term here is the 1. So there's no variable. So we need to figure out what to the 4th is equal to 1. Has to be 1. So it's 2x minus 1 to the 4th. And you always go the opposite direction and check to see if you got the right answer. You know that there should be 5 terms because of the exponent 4. You know that the first term is going to be, and I'll just do it quick down here, row 4, 0, multiplied by the first term to the exponent 4, and the second term to the exponent 0. You know this goes to 1. 4 choose 0 with your calculator gives you a 1. 2x to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16, x to the 4th times 1. And that produces our answer. All right, so good luck with the homework. If you have any questions, let me know.